Hello again, this is Mr. Thomas. This is a continuation of Chapter 7, Covalent Bonding. Lesson 2, Naming Molecules. Here's our essential questions for Lesson 2. So, what rules do you follow to name a binary molecular compound from its molecular formula? And how are acidic solutions named? Here's our topics and sections. So, naming binary molecular compounds, naming acids, and writing formulas from names. Here's our vocab. Oxyacid. That's going to be any acid that contains hydrogen in an oxyanion. An oxyanion is a polyatomic ion in which an element, usually a nonmetal, is bonded to one or more oxygen atoms. Naming binary molecular compounds. So, binary molecular compounds, those are going to be compounds made up of only two elements. An example would be carbon dioxide, carbon and oxygen. Prefixes, those are going to be used in the names of binary compounds to indicate the number of atoms of each nonmetal present. Writing the formulas and names of molecules. Binary molecular compound. So a binary molecular compound is going to be composed of only two nonmetal atoms. This is not going to include metal atoms or ions. So an example of this is going to be nitrous oxide. So you usually see this in laughing gas, or in cars for racing. So another name for it is dinitrogen monoxide. Di meaning two, nitrogen, nitrogen, mono meaning one, and oxide for oxygen. Dinitrogen monoxide. So, like I said, it's a gaseous anesthetic, or it's also used in racing. The naming of binary, non-metal molecular compounds uses the following rules. So, first rule is going to be the first element in the formula is always going to be named first. The second element is named using its root and then adding the suffix "ide" at the end. Prefixes, those are going to use to indicate the number of atoms of each element that are present in the compound. So for example, for nitrous oxide or dinitrogen monoxide, so nitrogen, N, is going to be the symbol for nitrogen. The second element, O, is going to be the root, oxy, and then we're going to add "ide" at the end. Here's a list of prefixes that we have. So since there's two atoms of nitrogen and one atom of oxygen, it's going to be dinitrogen monoxide. So di meaning two atoms of nitrogen, mono meaning one atom of oxygen, dinitrogen monoxide. So there's going to be exceptions to these rules too. One of them is going to be that you're never going to use the mono prefix for the first element, and if you're using a prefix that results in two consecutive vowels, one of the vowels is usually dropped to avoid awkward pronunciation. So, for example, carbon monoxide is not called monocarbon monoxide. It's just called carbon monoxide. So you don't use mono for this first element. For carbon monoxide, we're going to be calling it monoxide, not monooxide. So here's some examples. So we'll have carbon dioxide, CO2. Carbon, we'll use the full first element. Di, meaning two. Oxy for oxygen, and then ide for the suffix. Here we have P4O10, so tetra meaning 4, then we'll use the whole first element, phosphorus, dec meaning 10, ox for oxygen, and then ide for the suffix. SO3, that's going to be sulfur, we'll use the full first element, tri meaning 3, oxy for oxygen, and then ide for our suffix. N2O4, di for 2, nitrogen, we'll use the first element name, tech is going to be for the 4, oxy for oxygen, ide for the suffix. So here's some practice problems. So we have P2O5. So first we're going to analyze the problem. So you're given the formula. Here's the formula. The formula contains the elements and the number of atoms. So here's your elements given the symbols, and here's the number of atoms per element. So because only two different elements are present and both are nonmetals, the compound can be named using the rules for binary molecular compounds. So solve for the unknown. First name the elements involved in the compounds. So we have P, that's going to be for phosphorus. We're going to have oxide, oxygen. We're also going to add this suffix at the end. So we're going to put them together, phosphorus oxide. Now we can modify the name with the number of atoms. So phosphorus is going to have 2, oxygen is going to have 5. So we're left with di-phosphorus pentoxide. So evaluate the answer. So di meaning 2, pent meaning 5, oxy, oxygen, and ide for the suffix. So 2 phosphorus, 5 oxygen, so that's going to agree with the chemical formula P2O5. So naming binary molecular compounds. Common names for some molecular compounds. Have you ever heard of dihydrogen monoxide? Every person that's come into contact with this chemical has died. You've actually come in contact with it too. This is just H2O, water. So recall that many ionic compounds have common names in addition to scientific ones. For example, baking soda is also called sodium hydrogen carbonate, and common table salt is called sodium chloride. Many molecular compounds that we know today, such as nitrous oxide or water, were already given names previously before the present-day naming system was developed. So that's why we have many different names for the same thing. Other binary covalent compounds are generally known by their common names rather than their scientific ones. Some of them are going to be ammonia, that's NH3, hydrazine, N4H4, nitric oxide, NO. Naming acids. Water solutions of some molecules are acidic and are named as acids. We'll learn more about acids in a future topic. All you need to know about acids right now is that they're going to donate protons, or they're going to be donating hydrogens, or they're just hydrogen, H+. So if a compound produces hydrogen ions, H+, in a solution, it's called an acid. So for example, HCl produces H+ in a solution and is therefore an acid. Two common types of acids exist, binary acids and oxyacids. So we'll go into more detail on each one of those. Naming binary acids. So a binary acid is going to contain a hydrogen and one other element. So hydrochloric acid is going to contain hydrogen and then one other element. So in this case it's chlorine, so we have hydrogen and chlorine. These are our two elements. The naming of common binary acids, such as hydrochloric acid, is explained with the following rules. So the first word has the prefix hydro to name the hydrogen part of the compound. The rest of the first word is going to consist of the root of the second element plus the suffix ic or ic. So we have hydrogen and chlorine. So the first part, hydrogen, is going to be the prefix hydro. So hydro is the prefix. The root of chlorine is going to be chlor. So we have hydrochlor. And then we're going to end with the suffix ic. So hydrochloric. The second part is always going to be acid. So when we put it together, it's going to be hydrochloric acid. There are a few acids that also go by the binary acid naming rules. For example, if no oxygen is present in the formula for an acidic compound, the acid is still named in the same way as a binary acid. The only exception is that the second part of the name is the root of the polyatomic ion. For example, we have HCN, so it's made of hydrogen and cyanide, which is just carbon and nitrogen. The name for this acid is going to be hydrocyanic acid. So hydro is the prefix for hydrogen. Cyan is going to be the root of the second one. And then we're going to add ic at the end. And then lastly, we're going to add the word acid to the end of the whole thing. Hydro, cyan, ic, acid. Naming oxyacids. An acid that contains both a hydrogen atom and an oxyanion is referred to an oxyacid. So an oxyacid is going to be a polyatomic ion. So poly meaning many, atomic meaning atoms, so many atoms. So in this case we have HClO. So we have hydrogen, chlorine, and oxygen. The anion, remember an meaning negative, so the anion is going to be ClO. The name is going to be hypochlorite. And the oxyacid name is going to be hypochlorous acid. So that's just one example. So an oxyanion is a polyatomic ion containing one or more oxygens. So here are the rules in naming an oxyacid. We'll do nitric acid as an example. So first you want to identify the oxyanion present. And we'll go over more of these up ahead. So the first word of the oxyacid's name is going to be the root word of the oxyanion. If the oxyanion's name ends with ate, you're going to replace it with ic. If it ends with ite, you're going to replace it with us. So for example, NO3, that's going to be a nitrate ion. It's going to become nitric. So we have nitrate, it's going to be nitric now. And the second word's also always going to be acid. So for HNO3, NO3 is going to be our oxyanion. NO3 is called a nitrate ion. So when we name the acid HNO3, it's going to be called nitric acid. Naming oxyacids. So this table is going to show you how several oxyacids follow this rule. So HClO3, so chlorate is the oxyanion. Since we have ate at the end, we're going to have ic as a suffix. So it's going to be called chloric acid. Here we have chlorite. So since we have ite, we're going to change it to us. So chlorous acid. Here we have nitrate. It's going to be nitric. Nitrite. It's going to be nitrous. Notice also that hydrogen isn't in the name of an oxyacid. So this is going to be because all oxyacids are going to have H+. So you don't have to identify that it has hydro or have a hydrogen in its name. So this table summarizes the formulas and the names of several covalent compounds. So for example here we have H2O, the common name is going to be water. The molecular compound name is going to be dihydrogen monoxide. Here we have NH3, that's nitrogen trihydride. N2H4, dinitrogen tetrahydride. HCl, hydrochloric acid. Writing formulas from names. The name of a molecular compound is going to reveal its composition and also communicating the nature of the compound. So by now you should be able to write the correct chemical formula. So for prefixes, that's going to be the exact number of each atom present in a molecule, and it's going to determine the subscripts used in the formula. So subscripts are the little numbers at the bottom. So the formula can also be derived from the name. So if you have the formula, you can also give the name of the molecule. And remember, if we have a binary acid, it's always going to have a prefix hydro. Here's a whole list of polyatomic ions. The ones with oxygen in them are called oxyanions. NO2, that's called nitrite. NO3, that's nitrate. For example, here we have C2H3O2, that's called acetate. Then SO4, that's sulfate, so on and so forth. The flowchart in figure 12 can help you determine the name of a molecular covalent compound. So use the chart, work from top to bottom, and apply it to the formula of the compound that you want to name. So here we're going to start up here. So look at the formula of the molecule. Let's take, for example, HBr. So does the compound form an acidic aqueous solution? If yes, we'll go to the left. If no, we'll go to the right. So since HBr has hydrogen, it will form an acid. So now, is there an oxygen present in the compound? So is there oxygen in HBr? No. So we'll go to the left. So now we'll name it hydro, then the root of the second element, which is bromine. So the root of bromine would be brome, and then we'll add ic at the end. And after we finish the first word, the second word is always going to be acid. So when we put it together, it's going to be hydro, brome, ic, acid. All right, let's try the second one. So H2SO3. So does the compound form an acidic aqueous solution? So does it have hydrogen in it? Yes. So is there an oxygen present in the compound? Also yes. So we're going to have the root of the oxyanion present. Then we're going to have ic if it ends in ate, or us if it ends in ite. Then we'll have the word acid. So let's look back at our chart. So we have SO3. So SO3 is going to be sulfite. So it ends in ite. So we'll have us for the ending. Then our second word will be acid. We're going to have the root, sulfur, us, acid. All right, this last one. So we have NO2. So does this compound form an acidic aqueous solution? So does NO2 have hydrogen in it? No. So name the first element in the molecule. Check to see how many atoms of that element there are. If there's more than one, use the numerical prefix like di, tri, tetra. Now for the second element, see how many there are for the prefix. So if there's 1, 2, or 3, so mono, di, or tri. Then use the root word of the second element. Then add the suffix "ide" at the end. So nitrogen, di, meaning 2, ox, from oxygen, and then we're finishing with "ide." Nitrogen, dioxide. Alright, so here's some practice problems. So let's try silver chloride. Okay, so for silver chloride, so what I want to try to do now is look on a periodic table. So silver is Ag at atomic number 47. Chlorine is Cl at atomic number 17. Silver, which is Ag, and then chloride, which is going to be chlorine, so Cl. Here's dihydrogen oxide. Dihydrogen monoxide. So di meaning 2, hydro for hydrogen, and then mono meaning 1, oxy for oxygen. So the way we're going to write this is whenever we write the chemical formula, carbon is going to take precedence, so that's going to be first, hydrogen is next, and then the rest of the elements are in alphabetical order. So since we don't have any carbons here, so we'll have H, 2, and then 1 oxygen. Here's chlorine trifluoride. We're going to write chlorine, which is Cl, fluoride, it's going to be F, and we're going to have 3 down here. to indicate 3 fluorine atoms. Here's diphosphorus trioxide. For diphosphorus trioxide, let's go to our periodic table. So phosphorus is going to be P, oxide is going to be O. So we're going to go in alphabetical order. So it's O, 3, P, 2. So here's some challenges. So strontium acetate. So for strontium acetate, let's look at our periodic table. So strontium is going to be Sr, but we don't find acetate on here. So acetate is going to be one of our polyatomic ions. So acetate is our C2H3O2 negative. So when we're going to write this out, so strontium is going to be our strontium. It's going to be our Sr2 positive charge, and then acetate is going to be our C2H3O2 negative. So how many acetate molecules are we going to need to counteract strontium's 2+ charge? So we'll need 2 acetates. So when we write this out, we'll write it out. Carbon is going to have priority, then hydrogen, then the rest of the elements are going to go into alphabetical order. So we'll have C4, H6, O4, and then with strontium, we'll just have Sr. Here's carbonic acid. So for carbonic acid, since you see that it has ic at the end, you know that we've replaced it with ate. And also, since it's an acid, it's going to contain hydrogens. So for our polyatomic ions, so let's look back here. So let's try to find carbonate. CO3, 2-. So carbonate, that's going to be our CO3, 2-. And since it's an acid, our hydrogen is just going to be an H. So how many hydrogens are we going to need to counteract this 2- charge? So we'll need 2 of them. So remember the order that we're going to write this in. So carbon takes priority. Then how many hydrogens are we going to have? So H2, and then we'll finish off with the O3. So CH2O3.